Welcome to Module 3. Well, Module 3 is about real-world problems with numbers. So I'll illustrate those problems using some examples. So the first topic is percentages. You probably know how to use percentages. You use them all the time. But how do you know if you're using them correctly? Let's say somebody's talking to you in percentages. How do you know that somebody's telling you the truth? Let's investigate the percentages so that you're not scammed. Okay? When or how do we use percentages? Well, let's take a look at some of the examples. We use percentages as fractions or decimals. Say a question is 15% of the total population, student population, or 90 students were absent today. What is the total number of students at this particular school? Or you can use a percentage to describe change. For example, the price of a stock increased 75% from $50 per share. What is the final stock price? So let's take a look at one by one. Percentages could be used in fractions or decimals. To answer the first question, we have to do a little bit of algebra. In algebra, you use the variable to figure out the unknown. In this case, the unknown is total number of students, so let's put the x to that. 15% could be described as 15 over 100 or 0.15. Those are all equivalent. Typically, you want to use a decimal or fraction in your calculations. So 15% of the total population is 90. So to put that in the math, in algebra, that would be 0.15 multiplied by x, which equals 90 people. So to find the x, what you do is 90 divided by 0.15. If you punch that in your calculator, you get 600. So the total number of students is 600. You can also use percentages to describe change. And there are two types, absolute type and the relative one. The absolute change describes the actual increase or decrease. And the relative change describes the size of the change relative to the reference or the original value. So there are two formulas. To calculate the absolute one, you just subtract the new minus the original. To figure out the relative, the formula is absolute change over original, or using this formula up here, it will be new minus the original in parentheses divided by original. To find the growth or decline in values, here are more formulas. The growth formula is 1 plus p, p being the percentage increase, and you change that to a decimal point. So 1 plus p multiplied by the original. So if you shuffle this around, you can figure out the original given the growth. So growth or the n value divided by 1 plus p will give you the original. Similarly, the decline, the formula is 1 minus p times the original. So to figure out the original, if you have the decline value, it's going to be decline value divided by 1 minus p. So since the stock grew, let's use the growth formula to figure out the end value. So in this case, 75% increase, which is 0.75. So 1 plus 0.75 multiplied by 50 will be $87.50. The absolute difference would be $87.50 minus $50, and the difference is $37.50. So that's how you figure out the absolute difference. Let's do a few more examples. Say if a friend of yours or my friend Gary makes minimum wage, you make $50,000, and Gary's bragging that he got a 50% raise, and your company is giving a 5% raise. Who is better off? You cannot really compare the 50% and 5% between these two because you're not calculating the actual increase. So let's do that. Assuming that the minimum wage is $8.75, 50% of that would be 4.38. So he will be making $4.38 more. For you though, the increase is 5%. So 50,000 times 0.05 will be 2,500. So clearly you're better off in terms of the raises. You can use the percentages to figure out the relative change in percentages. Say the unemployment rate has risen more than a percentage point to 8.5% in February of this year from 7.1% from last year, last November. What is the relative change in the unemployment rate? So using the formula, this one, new minus the original divided by the original. So 7.1 will be the original, and the new number is 8.5. So 7.1 minus 8.5, put in the parentheses, divided by 8.5. You get negative 0.1647 if you punch it in 7.1 minus 0.071 minus 0.085 divided by 0.085. And what you want to do is change it to the percentages. Or if you can just, since we're all dealing with the percentages, you can just do 7.1 minus 8.5 divided by 8.5 and you get negative 16.47. So it's about a 16% decrease. All right, here's the one that you probably know. You purchase a shirt with the labeled or the pre-tax price of 21 bucks. The local sale tax rate is 6%. What is your final cost? What's the amount you pay including tax? Well, it's an increase of 6%. So you do 1 plus 0.6 or 0.06, which will be 1.06, and multiply that by 21. And you run it to 2 decimal points because that's how far we go in the real world. So $22.26. Moving on. Sometimes we deal with really big numbers, like trillions. So we'll see what this means with this example here. So let's see converting 30,000 years to seconds. So if you type this in your calculator or in Excel, you see something funky. So, oops, there's a typo here. So it's 3 here. 3,000 times years, and there's 365 days in a year, and there's 24 hours in a day, 60 minutes, and 60 seconds. So if you type this into your Excel, you get this thing with the E. What does this E stand for? Well, it stands for scientific notation. And if you do the same thing in your calculator, you probably see something similar to that. What does this E mean? Well, its actual number is this number, 94,608,000,000 seconds. Sometimes because of a space constraint or because the number is so big, what we do is we use scientific notation with this E. So if you do this in Excel, if you see an E, that is scientific notation. How do you convert from a raw number to a scientific notation? Well, let's say Chicago population 3.5 million. This is the same as 3.5, which is 3.500000. Basically, from the end, you count how many spots you gotta move in order to get to 3.5. 1, 2, 3, 4, 5, 6. So this is another way of scientific notation. 3.5 times 10 to the 6th power. Or it's the same thing as 3.5 e to the 6th. That's how you probably see in your calculator. So either way is correct for scientific notation. Let's try another example. Let's convert the distances from miles to inches and to the centimeters. So to calculate 1 million miles to inches, there's 63,360 inches per mile. So I'm multiplying those two numbers. And let's do this in Excel again. Here. And this is my scientific notation. 6.336 E plus 10. Okay. And then you can do the same thing to convert it to the centimeters. There's approximately 2.54 centimeters per inch. So if you copy this, put it here. So that'd be my number for centimeters. Okay. It's a plus because it's a bigger number. Is there a case where it's a negative? Surely. Let's say you were to split $2 among everybody on Earth, and then assuming the population on Earth is these many people, 684050703, how much does each person get? So that would be 2 divided by this number. So let's try that in Excel. 2 divided by this number. You see that E is negative. So this means it's really tiny. And what is the actual number? Well, you can extend Excel's cell to see how big it is. Or if it's not converting, you can right click on it, format cells. You can go to number, and it'll give you the actual number. Or if it's giving you the actual number but not the scientific notation, click on it, right click on it, format cells, and choose scientific. Press OK. You get the scientific notation number. Okay, so that's how you do scientific notation. Okay, moving on. Speaking of digits, accuracy and precision. So when you talk about decimal points, you will learn about the accuracy and precision. So here's a summary about what's significant and what's not significant in terms of how many digits you want to do. 90 digits always significant. This is significant. This is significant. This is not significant. And this is not significant unless stated otherwise. So for this to happen, the problems have to state, yeah, it is significant. It means something. Okay. So what does it mean to you? Well, what is the area of a rectangle? So I'll illustrate that by this example. The area of a rectangle whose dimensions are 7.786 millimeters and then 9.92. Give with 2 significant digits. Give with 4 significant digits. Okay. So let's do that. Those are the 2 numbers. Just copy and pasting so I can remember this. Okay. So this would be 7.786 times 9.92. Okay. So here, Excel gives you in 5 decimal points. I want to decrease it to 4 decimal points. So press on this. So this will be in terms of 4 decimal points. And if I go to 2 decimal points, this will be my up to 2 significant digits. Okay, so that's how you do this in Excel. One thing to note is to avoid errors, you want to wait rounding till the very end. You do not do the rounding in the intermediate steps. So that's one thing you should keep in mind. So wait till your last calculation here to either reduce your significant digits. Okay. So here's the definition of accuracy and precision. Accuracy describes how closely a measurement approximates the true value. So the accurate measurement is very close to the true value. Precision describes the amount of detail in the measurement. So how precise is it? So say your true weight is 52.55 kilograms. A scale at the health clinics that gives you weight measurements to the nearest half kilogram gives you your weight as 52.5 kilogram. A digital scale that gives you weight measurements to the nearest 0.01 kilogram gives you weight as 51.48 kilogram. Which scale is more precise and which one is more accurate? Well, the accurate is closer to the true value. So between these two numbers, 52.5 kilogram is more accurate because it's closer to the actual value. So the one at clinic is more accurate. The one at a digital scale gives you 51.48 kilogram. That means it has more digits, more significant digits. So that makes this one more precise because it gives you the weight in more detail. So this is more precise. This would be more accurate. Okay. So one of the real world application with the percentages is index number, and more importantly, the consumer price index number. So the index number is calculated by this formula. Value divided by the reference number times 100 to make it a percentages. So let's take a look at one example of consumer price index. Consumer price index, or CPI, you probably hear about it if you read the news or read the papers or watch the news. It is based on the average prices for a sample or more than 60,000 goods, services, and housing costs. The rate of inflation from one year to the next is usually defined as the relative change in the consumer price index. So that's how you figure out the rate of inflation using CPI. Alrighty. So question. Suppose the current price of a gasoline is 3.20 per gallon. Using 1975 price of 56.7 as the reference value, find the price index number for gasoline today. Well, in this case, you're given the index number and the value. So to figure out the reference value, what you do is index 3.20, which is the value, divided by the index number, which is 56.7. And I had to convert this to a dollar figure, so 0.567, because this is in cents, this is in dollars. So 3.20 divided by 0.567 is 5.64. So that's the price index number for this answer, for this problem. So to adjust the price for inflation, here's the formula you need to know. Price in dollar of Y or the latter year is equal to price in dollar of X or the prior year multiplied by CPI of the latter year divided by CPI of the prior year. And then X and Y are just in index in years. So everybody likes box of macaroni and cheese, so let's take a look at that one. A box of macaroni and cheese costs a quarter in 1976. What would be the price in 2005 dollars? The CPI in 1976 was 56.9, and the CPI in 2005 was 195.3. You're typically given the table such as this, so that's what I read. 1976 is 56.9, 2005 is 195.3. So following the formula, price in $X, which is the prior year, so it's a quarter, 0.25, times the CPI of the latter year, which is 2005, so that is 195.3, divided by 56.9, and if you do the math in your calculator, you get 86 cents. So the box of macaroni and cheese in 2005 will be 86 cents or $0.86. So that concludes the module on real-world applications.